Good afternoon. Now I'll continue the same electronic configuration. So previously, to write electronic configurations, three important things I was given. One is half bow principle, and in that Moeller diagram, and Hund's rule and Pauli's exclusion principle. To understand Moeller diagram, you must know energy of subshells. Energy of subshells depends on n plus L value. N plus L value, if more, energy of subshell is more. If two subshells have same n plus L value, then the subshell with lowest n value will have less energy. The subshell with more n value will have more energy. So you have more idea about that. 2p and 3s, the n plus L value, it's 2 plus 1 because 2 is the n value. For p subshell, L value is 1. For 3s, n value is 3. For s subshell, L value is 0. So what these are means these are n plus L value. 2 plus 1, 3, and 3 plus 0, 3. So 2p is less energetic than 3s. This is order of energy actually. So you know the energy order, everyone clearly, I think so. First 1s is less energetic, then 2s, then 2p, then 3s, then 3p, then 4s after 3d after 4p. This is the way of filling of electrons in various subshells by using Moeller diagram as well as energy of subshells. If you want, you can check whether I written correct or not. So 3d means it is 3 plus 2 because n value is 3. For d subshell, L value is 2. For 4p, it's the n value is 4 and L value is 1. 4 plus 1, 5. 3 plus 2, 5. But n value is low. N value here 3. N value here 4. N value is low here. So 3d has less energy than 4p. So half bow principle, what they said, by completing electrons in less energetic subshell, then we have to fill electrons in next energetic subshell by filling up of maximum electrons in their respective subshells. So what is the maximum number of electrons I was given? S has 2 electrons, P has 6 electrons, D has 10 and F has 14 like this. 4 is the difference. Many times I told. Today also I am telling means to write electronic configuration. So according to half bow, first we have to fill electrons, maximum number of electrons in less energetic subshell. Means first in which we have to fill electrons? 1s. Because this is the order of energy of various subshells. Please note it down all these things. Now we will write electronic configurations. If you know this already, they may feel bored, but sorry to say, you have to get more clarity and you have to listen also. Definitely we will get more practice. So remember this energy order, everyone. Certainly to write electronic configuration, we won't feel any difficulty. So this is also, please remember, S can have 2 electron maximum, any S. 1s or 2s, 3s, 4s, whatever, S can have maximum 2 electrons. Any p, whether 2p, 3p, 4p, whatever, p can have maximum 6 electrons. S can have maximum 2. D can have maximum 10. F can have maximum 14. So this order, how we got understood? I told you to write that Moeller diagram. Maximum of people are very good and they send also. They sent also to me in WhatsApp group, and this I told you to send 1s, then 2s, then 2p. 2p after 3s we have to fill, 3s after 3p you have to fill, 3p after 4s we have to fill, and 4s and 4p and 4d and 4f here, and 3d here, and 3p and 4s we have to fill. 4s after we have to fill 3d, 4p and 5s we have to fill. Do you remember this Moeller diagram? So please remember all these things. Certainly you can write electronic configuration. First we will fill S, 1s. So this is starting, this is ending. So 1s after again you have to start with 2s and ends with 2s only. Okay, 2s after completely filling, then electron must enter into 2p. This is starting. And this is, so 2p after what subshell you will fill? 3s. Here I written no, 3s after 3p you will fill. See, 1s, 2s, 2p, 3s, 2p, 3s. This is the way of filling of various subshells. 2p after 3s is ending. 3s after 3p is starting. 4s is ending. 4s after what you are filling? 3d. Remember this. Why I kept star understood? 3p after 3d we are not filling. 3p after 4s we are filling. 4s after 3d we are filling. This class I done already. I was uploaded already. But again why I am explaining? You may feel that old video like that. Few people are saying like that. So that's why I am explaining again. So freshly you can listen one more time. So 4s after 3d, 3d after 4p. Let's see how to write electronic configurations. Okay. So to write electronic configurations, you must know the elements. I will write one by one. So number 1, I am writing the serial number is nothing but atomic number. Atomic number is 1. Then number of electrons is 1. Atomic number is equal to, so this is very important, atomic number is equals to total number of electrons. Total number of electrons. What is atomic number? Atomic number is 1 for a hydrogen, means 1 electron is present in hydrogen. Atomic number is 6 for carbon, means 6 electrons present in carbon. Remember this? Of course, I was given isotopes, isobars already. Few people know that, few people don't know. Don't worry, I'll give you those also later. So atomic number is equals to total number of electrons. So hydrogen, first one atomic number. So that element is hydrogen. Element is hydrogen. Atomic number is 1, element is hydrogen. So first element is hydrogen. So in hydrogen what subshell we have to fill? Who is the least energetic subshell? That subshell we have to fill. Who is the least energetic subshell? 1s. So 1s we have to start filling. Okay. We have to fill electrons in 1s subshell. Those electrons we have to show or represent as power. Okay. 1s power 1. Don't call it like that. 1s1. That's it. 1s power 1. No. 1s1. Means 1 electron is present in 1s subshell and that electron belongs to hydrogen. That is the meaning. But S can have maximum how many electrons? Maximum 2 electrons. So next element is helium. In that also we will fill electron in 1s only, but we will write 1s2. So in helium 2 electrons are present, which is equal to atomic number. Understood? Why, sir, you write down like this 1s1 and 2s1? Better no, sir. It's very nice to see. No, first initially least energetic subshell must completely fill. So it's 1s2. Yes can have maximum 2 electrons. So 1s filled. Next we have to look at next energetic subshell. So 1s after which subshell is going to fill? Means 2s. So what is the third element? Third element is lithium. So it's 1s2, 2s1. Because the third electron must enter into 2s. Because 1s can have maximum 2 electrons. But lithium atomic number is 3. So therefore, the third electron must enter into 2s. We cannot write, sir, why sir, another subshell, it's waste. No sir, I will write 1s3. No, because S can have maximum 2 electrons only. So 1s2 and 2s1. Got it? So next one is 4. 4 is what? Mr. Beryllium. 4 electrons. So here only S can have maximum 2. Okay, this S can have maximum 2. Okay, the configuration is 1s2, 2s2. Because beryllium atomic number is 4. These powers you have to add. Those are equal to number of electrons. So 2 plus 2, 4. 4 electrons. Okay. Next, fifth one. So beryllium. Next boron. Boron is 1s2, 2s2, 2p1. Why 1s2, 2s2, 2p1? So 2s3, right? No. S can have maximum 2 electrons. Understanding? 5 electrons are present. Atomic number is 5. You have to remember 30 elements. Please. Okay. So fifth element is boron, and boron atomic number is 5. So 5 electrons are present. So why sir 5? Don't ask me. There is no reason behind it. Beryllium has 4 electrons. Boron has 5 electrons. That's it. Atomic number and number of electrons present in boron. 5 electrons. That's it. Why not 6? Don't ask me like that. 5 electrons are present. Why I have 2 hands? It's nature. Okay, like that. So boron has 5 electrons. So 5 electrons, how to fill? 2 in this, 2 in this, 1 in this. Because S can have maximum 2 electrons. Now, so 1s can have 2 electrons, 2s can have 2 electrons, and 2p will have 1 electron. The fifth electron enters into 2p. This is called differentiating electron. Differentiating electron enters into what subshell means you have to say 2p. Understood? Because previously these are belongs to beryllium itself, 1s2, 2s2. Which one is a default between beryllium and boron means this 2p is differentiating electron. Between lithium and beryllium, differentiating electron enters in 2s. But in lithium also differentiating electron enters into 2s itself. Understanding? But it's 2s1, it's 2s2, that's it. But in boron, the differentiating electron enters into what shell means second shell. Differentiating electron enters into what subshell means 2p. This is called differentiating electron. Please remember everyone. Differentiating electron. So actually this is first subshell and this is second. This is first shell. 1s is belongs to K shell and 2s and 2p are belongs to L shell. Those also you must remember. Understanding? So these are very, very important for us. So I will write this is belongs to K shell and these are belongs to L shell. You know now for K shell, yeah, that n value is 1. For L shell, the n value is 2. N, small n, n is equals to 1 K shell, n is equals to 2 L shell. Do you know this? Yes, L shell, 2 na? So L shell. Understood? So 5 we written. Next is sixth one. What is sixth one? Boron and carbon. So 1s2, 2s2 and 2p, 2. 2p you can fill up to 6 because p can have maximum 6 electrons, no? So 2 electrons here, 2 electrons here, 2 electrons here, 6 electrons over. P can have maximum 6 electrons. Next element also, 7th one is carbon. So 1s2, 2s2, 2p3. Next 8th one, 7th one, nitrogen and oxygen. And 1s2, 2s2, 2p4 like this. 8 elements over. So have a look and have a screenshot so that energy will have maximum subshells, how many you will have, and this Euler diagram also you can understand. Okay, so have a screenshot, 8 elements we written. Next I will write remaining. Okay, so up to oxygen we discussed. Next is, what is next? I will write here only, but because I will look at that energy and I will write. So I won't erase that side. So next, 9th one is fluorine. Its configuration is 1s2, 2s2. 1s after 2s will fill, 2s after 2p must fill. Now, fluorine means 9 electrons, 4 I written. Oh my god. Yeah. 2p4 I written, 2p4. Next 2p5. 1s2, 2s2, 2p5. I think carbon I written 2p2 and 2p3 nitrogen and 2p4 I written previously. Please check those. And now I am writing this 2p5. See, 2 plus 2 4, 4 plus 5, total 9. And 10th one is neon. Nitrogen, oxygen I written. So neon. So 1s2, 2s2 and 2p6. 2p6, this one. Differentiating electron enters into, differentiating means understood, last electron. Here 5th electron is a differentiating electron. Here 6th electron is a differentiating electron. Means in 2p. Because Electron enters into 2p subshell only. So what shell? Like that I'll ask you questions. In neon, the differentiating electron enters into what shell? Means L shell. Differentiating electron enters into what subshell? 2p. Like that I'll ask you. And one more thing, if last shell consists of 8 electrons, these 8 electrons are present now, 8 electrons present, 2 plus 6, 8 electrons, that is called octet configuration. So that's why this neon is inert gas. What that is? Inert gas. In previous I forgot to say helium also, even that has duplet configuration, helium, that is also noble gas or inert gas. Inert gas also called what, sir? Noble gas. Please remember. Why helium also noble gas? Because 1s means in K shell only 1s subshell only present. So in K shell that 1s subshell is present and that completely filled 1s2, because S can have maximum 2 electrons now. So helium also having completely filled configuration, shell was completely filled, therefore helium also noble gas. And neon noble gas, octet configuration. Octa means 8 electrons, 10 elements we discussed. Neon is what we discussed, differentiating electron we discussed, everything we discussed. Next, 11th one. 11th one is Mr. Sodium. Sodium is 11. 11th element, atomic number is 11, 11 electrons. Okay. So sodium has 11 electrons. 11 electrons, how to fill? So 2, 2, 6 and 1. Over now, 11 electrons, you only classify 11 electrons. 2 S can have 2, S can have 2, 4, P can have 6. So 4 plus 6, 10 and 11th electron enters into 3s. So differentiating electron enters into 3s in sodium. So what is the configuration? 1s2, 2s2, 2p6 and 3s1. Now this is called differentiating electron. 11th electron. Okay, last electron is called differentiating electron. I am not only writing electronic configuration, I am saying what shell and what is the differentiating electron. Here I told 6th electron is means in 2p 6th electron, otherwise 10th electron enters into 2p. Difference understanding? In 2p 6th electron and in this neon 10th electron present in 2p. 9th electron present in same. Okay, so like that. After 4 electrons, remaining 6 electrons present in 2p. That is the meaning. Understanding? So sodium over. Next, 12th one is Mr. Magnesium. Configuration is 1s2, 2s2, 2p6 and 3s only can have 2 electrons, so 3s2 I can write. Okay, next, 13th. 13th is what? Mr. Aluminium. Aluminium configuration is what? 1s2, 2s2, 2p6 and 3s2, 3p1. Because total 13 electrons, you can count whether it is correct or not. 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12 atomic number. Aluminium 13. 2, 2, 6, 10, 10 plus 2, 12, 12 plus 1, 13. Here, otherwise here, 2, 2, 6, 2, total 12 and 13, you know, so differentiating electron enters into 3p here. What shell if they ask? Third shell. Okay, that is what. Okay, very important. Differentiating electron enters into 3p in aluminium. Next, 14th one. 14th one is Mr. Silicon. 1s2 and 2s2, 2p6 and 3s2, 3p2 is the differentiating electron. Differentiating electron enters into 3p. Like that 3p can have maximum how many electrons? 6 electrons. Next, 15th one. What is that? Yeah. 15th one is Mr. Silicon phosphorus. Now 1s2, 2s2, 2p6 and 3s2, 3p3 is the phosphorus. Differentiating electron enters into 3p. Okay. As a shell wise, if you want, 3s 3p belongs to one shell, 2s 2p belongs to one shell, and 1s is one shell. This is K shell, this is L shell, and this is M shell. Remember all these things. M shell, third shell, N is equals to 1, you know this, N is equals to 1, K shell, N is equals to 2, L shell, N is equals to 3, M shell. So 3s and 3p comes under M shell. Okay. So differentiating electron enters into what shell if they ask? M shell or third shell. Don't forget, try to remember everything here. So 15 elements we discussed. So again you have to write all these things. So what here we discussed, what is the noble gas we discussed, and what is the inert gas, what is octet configuration, what is the differentiating electron, all those things we discussed. Next, 16 is sulfur. Sulfur is 1s2, 2s2 and 2p6 and 3s2, 3p4 is here. 10 plus 6, 16 electron. 17 is chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. And 18th one, again you have one different configuration, that is argon. So 1s2, 2s2, 2p6, 3s2, 3p6. So again here you have a octet configuration. Octet means in last shell if you get you have 8 electrons, that is called octet configuration. This is only last shell, no? Okay, last shell means highest n value. That is also called outermost shell. Different words I am using, all those words you have to remember. This is differentiating, highest n value is a differentiating shell. For argon, differentiating shell, otherwise outermost shell, or differentiating electron enters into what subshell. These all questions are very important. For argon, the outermost shell is third, that is called M shell, because highest n value is 3 here. Okay, this 2s and 2p, so this is suppose n and this 2 na, so n minus 1, this is called penultimate shell. This is anti-penultimate shell. Remember all these things. Highest if n, so 3 is the n, so 3 minus 1, 2 is the penultimate shell, and remaining are anti-penultimate shells. Remember only two. One is outermost shell or ultimate. Ultimate means outermost. Last shell, in which the last electron enter, is called outermost shell. See, in argon, that 18th electron enters into 3p only, na? So 3p belongs to third shell, na? So 3s and 3p are belongs to third shell, which is called M shell. So 3s and 3p are outermost shell subshells. Okay, so very important. 18 we discussed. Next 19, very important. Write down all these things. I am not only giving electronic configuration, or I am giving what is outermost, what is penultimate, what is anti-penultimate, everything. 19, and 19th is potassium. Potassium configuration is 1s2, 2s2, 2p6, 3s2, 3p7. Can we write 3p7? See, 10 plus 2, 12 plus 7, 19. Over na? No, because 3p, p can have maximum how many electrons? 6, 3p6. So 3p after what subshell we are going to fill? 4s. So 3p after we have to fill 4s. So 3p6 and 4s1. Now who is the outermost? Tell me, sir. For potassium, who is the outermost? Highest n value. 4 is the outermost. In potassium, differentiating electron enters into what subshell? 4s. In potassium, in what shell the last electron enters means n shell. N is equals to 4, that is capital N shell. So last electron enters into 4s. Last electron enters into n shell. Please try to focus, and these are very important questions for us. So next 20th one is Mr. Calcium. It's a 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. So 20 elements electronic configuration we discussed by using this. After 4s, next 4s was completely filled in calcium. So next 21st, actually 21st is a scandium. From scandium, actually up to calcium 4s was filled. So from scandium 3D will fill. So D can have maximum how many electrons? 10 electrons. So 10 elements you can fill electrons in 3D subshell, starting from scandium and ending with zinc. So 3D1 to 3D10 we can fill. From scandium means 3D1 and last 30th element is zinc. We will have 3D10 there. Of course, in between there are two exceptional cases. One is chromium and another is copper. So please note it down all these things. So now we will write electronic configurations of remaining 10 elements from scandium to zinc. So you have a clarity, and I guess you will have some clarity. Okay, still if you have doubts, no problem, please ask me, I'll explain. Potassium, the outermost electron enters into 4s. In calcium also, outermost electron enters into 4s. Outermost means differentiating electron enters into last shell. So this is outermost, and 3s and 3p are penultimate, and now 2s and 2p and this 1s are anti-penultimate. Both are anti-penultimate only. So highest n value, n is equals to 4, n minus 1 is penultimate. Okay, I'll ask you questions after class. What is penultimate for penultimate shell for potassium, like that you have to answer. Okay, so up to how many elements we discussed? We discussed up to 30 elements. Atomic number means what I told you here. Atomic number gives you the number of electrons present in an atom. So we have element and electronic configuration here. So atomic number next 21. 21 is scandium. Scandium have how many electrons? 21. How to fill 28? 1s to 4s. Up to here is 20 electrons. 2 plus 2, 4, 4 plus 6, 10. 10 plus 2, 12. 12 plus 6, 18. 18 plus 2, 20. So 21 electron. So 21 electron enters into 3D or not? We have no need to write electronic configurations. What is the differentiating subshell for scandium means? If you know these energies, you can add electrons. 2 plus 2 plus 6 plus 2 plus 6 plus 2 till here 20. Okay, 21. Okay, last electron. The 21st electron in scandium is the last electron. That last electron enters into 3D or no? So differentiating electron enters into what subshell for scandium means 3 over. So scandium is configuration is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2 and 3d1. Shell wise means 4s will come last and 3d will come here. Shell wise means, but electron filling in the same order, no need to confuse. But 3d comes under third shell itself. This belongs to K shell, these two belongs to L shell, these two and this, these two and this combinedly comes under M shell. But 3p after 4s is going to fill, 4s after 3d is going to fill. That is very important. Scandium after, so remember 22 scandium, titanium configuration 1s2, 2s2, 2p6 and 3s2, 3p6 and 4s2, 3d2. 3s, 3p, 3d belongs to one shell only, but 4s after 3d is filling. Remember this. Next 23. Titanium, vanadium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 3h. Next 24 is chromium. Is chromium configuration. Chromium is 24. Why I am using different black color here? You will have some exceptional case here. So 24th is chromium. Its configuration is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2, 3d4. Actually we expect this. But do you remember I was given in previous half filled or completely filled are more stable. So actually this won't be applicable for remaining S and P. So don't compare these elements with piece of shell, then carbon 2s2, 2p2, then 2s1, 2p3 if you take 2p3. So p3 half filled, that is more stable. No sir, can we take, means energy gap is high. So there is no exceptional case in previous. But in case of chromium there is an exceptional configuration here and 4s2, 3d4, but instead of this the configuration is 4s1, 3d5, the most important configuration here. Why? Means here 3d subshell half filled. D can have maximum 10 electrons completely filled, but 5 means half. Half means more stable, I told or not? Of course completely filled is more stable than half filled, but half filled also more stable, but 4s and 3d energy gap is less. That's why from S 1 electron jumps into 3d. That's why instead of 4s2, 3d4, 1 electron jumps there. So 4s1, 3d5. Please remember this one. 24. Chromium is the exceptional case. Chromium. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. 4s1, 3d5. 4s2, 3d4 actually. According to Aufbau principle, 4s have to completely fill, then electron enters into 3d, but still 1 electron transferred here. Again is to Aufbau principle. Actually it was not completely filled, 1 electron transferred, but why transferred? To become more stable. So chromium configuration 4s1, 3d5. Why 4s1, 3d5 understood? Because half filled configuration is more stable. Understood sir? Next 25 chromium, manganese, 26 is iron and 27 is iron, cobalt and 28 is nickel and 29 is copper, 29 is copper and 30 is zinc. So you write down again zinc has copper has exceptional configuration 29. So you can write till here no change. 25 is 1s2, 2s2, 2p6, 3s2, 3p6. Now 4s2, 3d5. In previous 4s1, 3d5. Why 4s1, 3d5? 1 electron jump there. Don't write here 4s1, 3d6. No. 4s2, 3d5. 3d5 half filled stable, no? That's why. So manganese 4s2, 3d5. Next iron. Same story. D you have to increase. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Next cobalt. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. Same story for nickel. 4s2, 3d8. Nickel, copper, zinc. So don't get confused. So these are the electronic configuration. Have a screenshot and write down. Chromium is the exceptional configuration there. Chromium. Nickel also you can write. Okay. So up to 28 we discussed. Now I will give you remaining also. Remaining means only just 3 elements. One is 28. 28 one is nickel. Its configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3p6 and 4s2, 3d8. I will give you one trick everywhere. 28. Here you have that configuration. 28. 4s2, 3d8. 28. See 28. 4s2, 3d8. Remaining all. But exception is chromium and copper. So 29 actually. 29 is copper, which is exceptional again. What we write configuration actually we expected. 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2, 3d9 actually. 28 4s2 3d8, 4s2 3d9, 29 like this. But here you have an exceptional, because there is a possibility of completely filled. Sir, then these two if go, then 4s0 3d10, completely 2 electrons, nobody will donate. Completely will you donate your money? No. If you have some amount, you will give some amount. Correct? You won't donate complete total amount what you have. Some extent you will donate, like that 4s1 and 3d. 4s1 okay, but 4s0 3d10 not possible. Okay, but here also why one electron transferring from here to here? Because 4s1 is stable, that's why it is transferring. No, 3d10 is more stable, that's why it is transferring. So what is the configuration? It is one electron transferred. So 4s1 3d10 is a copper electronic configuration. In this manner only you have to remember, otherwise in CBSE students will learn like this, 2, 8 like that, okay, and 2 plus 6 plus 10 like that, 18 and 1 like that they will remember. That is not the correct manner actually, because to understand chemical bonding, or the element belongs to what period, what group, the element belongs to what shell, what block, S block, P block, D block in periodic table. This kind of electronic configuration you must know. Copper is the exceptional configuration. Next 30 is a zinc. Its configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. The same configuration you can write like this. Filling is like this. Configuration you can write like this: 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. In few books they represent like this, shell wise. This is also correct. But filling, after 4s only we will fill 3d. Shell wise they represent like this: 2, 8, 18 and 2. Zinc. But don't remember like this. Remember in this way only, subshell wise. So two exceptional configurations we discussed. One is one is chromium and copper. Okay. Remaining also we will discuss in our next class, like ions configuration and all. Thank you very much.